Hello and welcome back to another episode of Math with Son. Today we are going to be talking about taking our 2D kinematics and launching it from an angle, but specifically from an angle that has a height. Okay, so that height is going to be 40 meters above the ground. We are traveling and launching this cannonball out 50 meters per second at 30 degrees. We want to find the maximum height of the cannonball, which can be found a few different ways, but I like to do it with two steps. And first of all, finding out the time it would reach that maximum height. Okay, so in order to do that, we would only be focusing on the y component, and the y component would have it going up and then back down, which means the final velocity for the y component would be equal to 0. So if we use our kinematic equation, velocity final for the y component would equal the initial component plus a times t. All right, well, with that in mind, we could and know what our y component is. It is going to be, for our final, would be 0. Our initial would be, it's the y component. Remember that the y component relates to sine, so that would be v times sine of 30 minus 9.8 times t, which is a much easier equation to solve than some of these other ones. So if we do that, we end up with, what is our v? Our v is 50, so 50 times sine of 30, 50 times sine of 30, sine of 30 is 1/2, half of 50 is 25, minus 9.8 times t equals 0. Negative 25 would equal negative 9.8 t. And if we divide 25 by 9.8, you end up with a time that is 2.55 seconds. Beautiful. With the time of 2.55 seconds, that is what I would use to find the maximum height. Okay, so that would mean that I would use this kinematic equation, which is y equals y sub 0 plus v0t plus 1/2 at squared. Okay, so then I use a different kinematic equation and I solve for the actual height. So y final, you can put an F there for final, will equal the initial height. Well, what's the initial height? It was up 40 meters above the ground. So your final height would equal 40 plus your initial velocity times time. Well, the initial velocity was v sine of 30, which was 25 sine of 30, the y component of that cannon being blasted out, which was 25 times t. We just found out t is 2.55. Plus 1/2 times negative 9.8 times 2.55 squared. And then you just type that in your calculator and you get your answer. 40 plus 25 times 2.55 plus negative 4.9 times 2.55 squared ends up being a final height of 71.887 meters. So not as high as we would have thought, but it was also launched from 30 degrees. That's not as high in the vertical compartment as the horizontal compartment. All right, so let's remember those two things. Let's specifically maybe remember the time. It might come into play. Calculate the horizontal distance traveled by the cannonball. It does not matter. The horizontal distance has nothing to do with the maximum height, unless we're talking about the horizontal distance traveled by the cannonball when it reaches the maximum height, but I think it wants to know the actual horizontal distance when it hits the ground again. So, with that in mind, the horizontal distance traveled by the cannonball, we would need to figure out when the change in y is equal to negative 40 meters, because it started at 40 meters. We need it to be at 40 meters and then go and land on the ground 40 meters below the ground, which would be at 0. Not below the ground, 40 meters below where it started, which is at a height of 0 meters. So that is delta y is equal to negative 40. All right, well, let's do a little bit of math here. We got delta y formula is equal to v sub 0 times t plus 1/2 at squared. These are all from your kinematic equations. It's one we even use today. It's the delta x one. I just changed it to delta y. Well, I guess I'm not doing this. It's the middle one, but I use delta y because we're dealing with the y component. Delta y is equal to negative 40. equals v sub 0. What is the initial velocity? Well, the initial velocity, again, was 25 because we did 1/2. It was the v times sine theta. 1/2 sine of 30 is 1/2 times 50, ends up being 25 times t. We don't know t. Plus 1/2 times negative 9.8 times t squared. We could solve this equation. If we solve this equation, you can use a quadratic solver. You could use the quadratic formula. You could do a whole bunch of things. I am going to type it in my graphing calculator as quick as humanly possible to not waste your time. All right, plus 25x plus 40 graph weight. It is, according to my graphing calculator and looking at it, zoom in. And again, need to get quadratic solver on this one. 6.38. 6.38. So that means that the time that it landed was 6.38, which was a little bit more than double the time that it reached its maximum height because it didn't launch from the ground. Once we know the time it hits the ground, then we can find how far it has traveled during that time frame, because we can figure out the horizontal component. The horizontal component, we're still on part B, would be v times cosine of 30 degrees. Well, that would be 50 times cosine of 30, and 50 times cosine of 30 is not 25. It is 43.3. So that means 43.3. That means that the horizontal component is permanently 43.3. And if the horizontal component is permanently 43.3, you can multiply that by time, times time, and we found out the time that it was going for until it hit the ground was 6.38. If we multiply those together, you get a time, not a time, a distance of 276.26 meters. 276.26 meters. And that makes sense because it's going essentially 43 meters every second. And it was traveling for 6.38 seconds. So you can just multiply 43 times 6.38 and get 276. Part B, done. Part C, we are about to do. For part C, calculate the velocity in which the cannonball hits the ground. This is going to be the hardest part of this, because we would need to understand the triangle that was occurring on the way up and the way down. So rotate my paper again. On the way up and the way down, we need to understand that the horizontal velocity is permanently 270, not 270, it is permanently 43.3 meters per second. The vertical velocity when it hits the ground, we don't know yet, but we need to figure out the actual velocity, which is that angled part, which combines the vertical and the horizontal parts. So we got the horizontal, 43.3. We don't know the vertical yet, and we're aiming to find the hypotenuse to get the combined effort. So we're going to eventually do the Pythagorean theorem. In order to do that, we need to figure out the final velocity for y first. Okay, so the final velocity for y is going to be found out by using v final equals v initial plus a times t. We want it when it hits the ground, so that t is going to be what we found out earlier, which was the 6.38. The initial is, again, the same initial that it got launched with, v times sine of 30 degrees, which the v is 50. So we got 50 sine of 30 minus 9.8 times time, which is 6.38, would equal our v final for y. All right, so this is 25 minus, I'm expecting this to be negative, 25 minus 9.8 times 6.38 is final answer for Vy. I did that all in my calculator, is negative 37.52 for, which should make sense because it's going down. when it hits the ground. So 37.524. In order to find the actual final velocity, we need to be able to combine this 43 to the right and this 37 to the downward direction, which are not just going to be as simple as just adding them together, unfortunately. Use the Pythagorean theorem. So our true final velocity for both x and y will be that squared, and then the 37.52 squared for the y, and the 43.3 squared for the x. And we do the Pythagorean theorem. 37.52 squared plus 43.3 squared equals a big number, and you square root that big number. You square root the 3282, and you get 57.28. So your actual velocity final will equal 57, I don't know why I said 28, it's 57.29 meters per second. That would be the true velocity because it's going down 37 and over by 43, but really when you combine them, because you're not going down and over separately, you're going down at this diagonally distance. And that would have a true velocity for your final part of 57.29 meters per second. That's going to do it for this one. Until next time, stay positive, and I will see y'all later. Bye.